Hi guys, welcome back to another video. So a few months ago, a few houses down from mine, they're throwing out 2 old TVs. This is one of them. The other one's over here. It's a curved Panasonic TV. There'll be a video for another day. But anyways, this was a few houses down, and this TV is so heavy. It has to be at least 70 pounds. I had to lug this thing all the way home from down the street, but luckily I got it home. It's been sitting under the deck on a pallet with a tarp on it for a little while now. That's why it's kind of muddy. I actually talked to the guy about this TV who was throwing it out. He said there was a power supply problem with some film capacitors and stuff, and he said that replacing the film capacitors didn't fix anything. And he claimed that it was a more sophisticated problem with the power supply. So I don't think it's really worth trying to fix it all. So we're going to take it apart. This is a 55-inch plasma screen TV. It's a fairly new TV, so not too old. So first I'm going to try and get the base off of it so I can lay it down flat. Okay, so here's the base. This actually has dual subwoofers on it. Pretty cool. I think one of those might be a passive radiator though. It's got 4 fans on it too. So let's try and figure out how this... There's a lot of screws missing. You can see that it's missing the cover for the plug on the back. So that probably got lost, or he never put it back on or something. But it's got a big ferrite core on it. That's pretty cool. Looks like this would just unplug. There's 2 little clips here that you have to push down to pull it out. You can see it's missing several screws for the stand. Looks like 2 screws here. I think this holds on the bottom part of the stand. Okay, it's kind of loose now. There might be some screws on the bottom I have to take out, so I have to figure out how to get to those without tipping the TV over. Yeah, there's a few screws under here. You know what, I think it would just be easier to take these out. I think if you take these 2 out, you'll be able to pull the actual TV off from the bracket from the stand. So let's try that. Okay, I think it wants to bolt right off. So this is going to be a pain to lift. No, there's still something holding it on. Maybe we can try scooching it forward. Yeah, I think we have to take those screws off on the bottom. I'm kind of hesitant to take out the last one without the TV being sturdy. Okay, honestly, I think I'm gonna break something doing this. Ooh, that's not good. Yeah, something's breaking. Oh, there we go. Now look at those big brackets. Those are like solid cast aluminum. Okay, let's set that down to look at this real quick. I'm not sure what these 2 screws were holding on. It looks like they just go through to the steel plate on the bottom and holds these brackets on secure. There's 2 more screws holding the, I almost want to call these fork brackets. That's kind of what comes to mind. Oh, that just slides right out. Yeah, it's a nice solid piece of aluminum. Yeah, these have to be able to hold a lot of weight with a TV this heavy. The bottom's all scratched up. I bet that's from having to stop every 2 feet to rest when I was trying to get it home. This piece here, it's got kind of a bow to it. That's probably because of that cracking I heard. I'm not going to go any further into this. This is not very interesting. Okay, let's just lay this TV down. Oh, that's heavy. You can see that there's a ton of screws missing. All along the side there, all along the top, most of them are missing. They probably didn't care to put the screws back in knowing that they were going to pitch it. Okay, there's a few screws over here. It's a very floppy cover. Let's look at the label real quick. Plasma HDTV 55-inch. 438 watt. Oh, I was wrong. April 2011. That's only like 7 years old. 120 volt, 60 hertz, assembled in Mexico. Yeah, this cover is really floppy. Oh boy, look at all that. Oh, look at how sophisticated that is. Let's take a closer look. You can see there are 2 fans, but in the back cover there was an option for 2 fans, so rather they weren't necessary, or it would have been cheaper to make without the 4 fans. So it's weird how they're only on the one side and not the other. I would think that they would evenly space them out rather than just having them on one side. So here's the power supply board. Nice big LCD controller board, it looks like. There's a motherboard and another LCD control board. You can see the subs. Cool. Yeah, this TV is really built well. Look at all those screws. There's got to be hundreds of them. You can see the big reinforcement bars for when it would be hung on a wall. That's what these are for. Would connect to the wall if you were mounting it on the wall. And here's where those big aluminum pieces went in and screwed in for the base. So I don't know what to start with. I'm kind of curious about the subs. There's only 3 screws for some reason. Got all these nifty little connectors going to everything. So here's the shallow subwoofer and passive radiator. You can see these big grommets to keep it from vibrating. You can see there's 2 magnets here for probably one of those double speakers that you see in some TVs. Ton of screws holding it on. Very well built. You can see here where the back cover actually mounted to the speaker bracket here and here. So maybe that's one of the reasons why it's so beefy. It's because I had to hold on the... Pretty neat how they utilize the space in these TVs, using all the brackets and stuff to hold other things on. It's pretty cool engineering. And cable management in this TV is really nice. It's a lot nicer than what you typically see on most TVs. So here's that bracket. Yeah, it looks like we have some double speakers. The cones aren't connected like a lot of them that I've seen, but it's still a double speaker, but it's still pretty cool. Let's see if we can get this big aluminum bracket off. All these little clips holding down the wires here. Yeah, there's lots of screws holding this on. They really had to build this up to make it strong. It's pretty cool to see all the structural engineering in here. Yeah, those big ol' screws too. Okay, the big plate's coming off. There's the big metal plate. You can see these long reinforcement bars here that stretch along the length of the TV. And the vertical ones up here too, the big vertical braces. These had 3 big screws connecting it on. Same thing with this one. This had a big screw going through it on both sides. So yeah, it would really take the load. Okay, let's look at this little power connector module here. This is what the power cord plugged into. Okay, this just comes off. Those are weird, they just clip into the little holes in the circuit board. That's pretty cool. So there's got to be something in this module. Looks like there's just these little tabs. Probably some kind of filtering in here. Yeah, so that's the filter. This would filter the raw power from the house. It would protect the TV from power surges and that kind of stuff. So having something like this can save your TV. Okay, this connects over here to this board. I don't know why the connectors are mounted at an angle like that. Maybe it's just for cable management or something. So that's the main power input. This is probably more filtering. So here's the board. Those traces are really huge. This is taking a lot of power. Oh, there's some power converters under there. There's a few relays and chokes and stuff. This is just more power filtering. You could almost say this is like the pre-power supply that feeds the main power supply, which is this big board up here. This is the connector that the filtered power would be coming in from the filter board, from the power filter board to the main power supply. Oh, this is weird. Look, it's like a little connector that just has a little loop of wire in it. That's really weird. Just plugs right in. Here's the output connectors that bring the high voltage, because this board here both steps up the voltage for the plasma display and it steps down the voltage for the other components, like the processor board over here. So it has two jobs basically. It steps up the power and it steps down the power, both in different circuits. Okay, so here's this board. You can see it's a very small form factor. A lot of heat sinks. Those are probably power regulators and big power transistors and that kind of stuff. These are probably the step-up transformers. You can see the big traces on the bottom side. There's a lot of power resistors on the bottom here. 5 watt, 18 ohm. A lot of capacitors on here. They all look like the same rating. A lot of fuses on this. There's a fuse here, fuse down there. There are several fuses on this board here too. Lots of fuses to ensure the fuse blows and not another component. On one side it says cold, on the other it says hot. Wonder why that is. Yeah, look at those, just little resistors just tacked on there for whatever reason. Okay, let's look over here at the motherboard. This would do all the digital processing. This is the main board. Just like the motherboard in the computer, so all the inputs would be processed in this board. Yeah, these are kind of weird connect. You pull up on them. Just is going to have like 5 volts, 4 volts, 1.5 volts, 1 volt for all the low voltage systems on this board. A lot of flat flex cables. You can see that all the flat flex cables running from the main board to all the other boards. This would be controlling the other boards. Okay, here's the board. There's a heatsink on the bottom too. I'm gonna try and get these clips off. These little clips that you squeeze and they pull through. Okay, so here's the heatsink. You can see the 2 little indents, or what was on the processors. There's nice little thermal pads. Yeah, I don't recognize any of those markings on there, but you might be able to find the data sheet on these. That would be neat. There's this weird little piece here on the board, little break off that says cut only 24 volts. Doesn't have any traces that connect to anything. That's kind of weird. Okay, let's try and get this other one off. This one must produce more heat. It has a heatsink on the bottom too. Oh wow, that looks just like a computer processor. How cool is that? No markings on that either. So it looks like this is the main controller here. And then maybe these are like the interface controllers, because you can see all the traces go directly from the main CPU. You can see they go all the way up to all the connectors. And then they go over here to these 2 chips. They're exactly the same to these connectors that connect to the other boards. So these chips would be controlling the panel controllers on the side here. So this would be all the digital signals going from the chips to the LCD controllers to the LCD boards. Okay, here's one of the backlight controller boards. So this would control the backlights. You can see all the high voltage capacitors and probably some high voltage components under here. All these control boards would be directly interfaced with this board here. Oh, you know, these look like almost large contact points. Here are these screws. So those might be just board-to-board bus connector. See, these would be direct contact points to connect the high voltage from both boards. You can see how big those traces are. Yeah, those would be for the high voltage backlight. Okay, here's the connector from the high voltage side of the power supply. Yeah, you can see these are specifically board to board. Those screws just go right through to the contacts on one board to the other. They actually cut out some of the PCB in order to make the capacitors lay flatter. I don't know what's under these heat sinks. Let's just pop one off. Okay, so under here is high voltage transistor. Those big inductors are huge, holy cow. That's like 12 gauge wire. See the cutouts for the film capacitors too. It's got board to board bus, is so cool. The other side is probably like that too. So on this side you can actually see the controllers. These are the actual controllers for all the pixels on the screen. Over on that side was just for the high voltage backlight, and then this controller here would control all the lines of pixels going horizontally, and then the one down here would be controlling the pixels vertically. You can see this one has an even bigger power board. These screens use a lot of power. You can see there are hundreds of traces in these flex cables. These board-to-board connectors are really neat. There's the connector from the motherboard. There's the connector from the power supply. Oh, I think this has the same kind of board-to-board bus connector system. You can see here. For a plasma TV, even the pixels, they still require a lot of power. And you can see all these individual heat sinks for the controllers under here. Yeah, so there's the connectors for the board-to-board bus. More of those high power components. Really cool. Okay, you can see all the big LCD controller ICs here and all the ribbon cables that corresponds to the horizontal lines of pixels. So let's just take this off. Okay, these little connectors flip up from the back side. There's another connector here connecting these two boards together. So here's the two controller boards. They look pretty identical. Let's just pop one of these heat sinks off. There's like two chips and then big globs of thermal glue. I can't really get any of this glue off, but there's just little chips. Each one of these probably corresponds to one of the plugs. You can see on these there's hundreds of little connectors in there. Okay, let's take off these fans. These look awfully similar just to standard computer fans, just with a little bezel to kind of guide the airflow. These are on the same little anti-vibration grommets as the speakers. Here's the fan, kind of an interesting design. It's 10 volt DC, 0.04 amp, neat little fan. I think they put the fans on this side because the extra power supply filter board was here rather than over there. So maybe this side over here produced more heat with the two power supply boards rather than the other side with just the motherboard. So maybe that's why they're on this side and not the other side. Yeah, everything on here is all connected with these nice little connectors. There's the other fan. I'm just going to take out this wiring. These little wire management guides are really neat. Okay, now let's look at the bottom LCD control board. This one is really long. Okay, I'm just going to take off this other speaker. Okay, here's the other bracket and here's the other speaker. You can see there's two ribbon cables from the motherboard to the vertical LCD control board rather than just one like the other side, because it controls more vertical rays of pixels than the horizontal side. So here's the power button here. This is a LED indicator board, and it has a infrared receiver that would receive the infrared light from the remote. There's some more LED indicator lights. Okay, so there's this big metal bracket here covering up the LCD control board under it with lots of screws, so let's take that out. Okay, there's this little bracket here for something. It's almost looks like a handle. These screws look like they have to come out. Okay, it looks like this whole plastic bezel on the bottom of the TV here needs to come off before it'll let this bracket come off. Okay, so over here, there's another bracket on top of this before it'll let this one go. So there's these brackets on the other side that have to come off first. So we have to take this off. It's got screws on the side here. This might just be a structural bracket. Adds support to the TV. You can see this is still not coming out. There's something holding it down, but it comes up enough to let this bracket come out. Okay, it looks like the whole LCD wants to come out. So somewhere, I think there's some screws holding it on up here at the top that I have to take out. So there are screws on the side that screw this outer bezel onto the LCD frame. So in order to remove the LCD from the bezel assembly, I have to take out these side screws. There's a Panasonic label up here. It says it's made in Japan. They make a lot of plasma and LCD TVs in Japan. Okay, there's more of those side screws on this side. There's a little button assembly here for the channel and volume buttons. Looks like just this plastic board comes off. Yeah, it's just a little plastic piece with a circuit board inside for the buttons. Okay, here's the whole LCD panel gonna come up now. Okay, here's the front glass and bezel assembly. So here's the front glass and outside bezel assembly. Then here's the actual LCD panel. This glass panel right here is really heavy. This is gonna be a pain to get rid of. I don't know what I'm gonna do with a big sheet of glass. Okay, so let's lay the LCD panel back down. Okay, now I think we can take those side panel pieces off that we were trying to get off earlier. Okay, it looks like it's taped onto the underside of the screen. I'll just have to hold it up while I unpeel it. No, I'm just using a razor to cut that. tape on this. It's that woven electrical tape. Now the one on the back here should come off just the same way. Okay, there's tape holding this one on too. Okay, there we go. That big bracket came out. You can see the big reinforcement bar here, just like there's one parallel to it on the bottom for more support and structural integrity. Okay, let's take off this one here. Oh yeah, I already undid the screws on this. I just gotta cut the tape. Okay, there's that bracket. Okay, now this bottom one will come off too. Okay, there's that. Yeah, it looks like there are these little heat sinks. Same way the other connectors were. Yeah, there's the chip. You can see the little black bar right there is the chip. Then this aluminum piece acts as the heat sink. The screws would go through here and hold these down, and the rest of the metal assembly would dissipate more heat. Yeah, there's lots of them. Yeah, there's this little board-to-board connector here. Another one over here. A lot of connectors in this ribbon cable. A lot of processing. Okay, let's take these boards off. These boards look a lot simpler than the horizontal LCD control boards. Yeah, a lot less components on this. Just a lot of connectors. Okay, there's one more down here. Man, this is really a neat TV. This is really well built and neat to see. This is a really neat teardown so far. I'm excited to see the actual LCD panel parts. Okay, so there's another board up here. Okay, you got all those controllers there. So I'm gonna flip this over so we can work on the other side. Oh, wait a second. This is interesting. What's this? You can see there's this little bracket here that comes up and covers this little glass tube. So there's some kind of gas in it or something. You know, just like a CRT tube, it's got some kind of gas in it. That's weird. I've never seen an LCD panel that has had a gas seal off like that. That's pretty interesting. I bet that's probably for something with the plasma technology. Now if we take a closer look at this LCD panel, you can start to see the actual pixels. Each one of those little bars is a pixel. More on that later. Okay, so there's this tape over here covering the panel. Okay, so there's something else that has to be holding this on. It can't just be that tape. You know, I may not be able to go any deeper into this. This is all glued together. There are two glass panels in the TVs like this. So one panel for the horizontal pixels, then the other one would be for the vertical pixels. If I can get this apart anymore, I'll try and show it. So over here you can see that glass seal off tube. Then you can see the two glass panels. You can see how there's two panels. This might not even have a backlight. That's so weird. I think it just puts a high power directly into the LCD. So you have the two panels. You can see these connectors go to the top one for the vertical pixels, and then this one right here goes to the, the ones on the other side. Hold on. So you can see like the two panels, like I said. There's the controllers for the top one. You can see those go to the top one for the vertical rays of pixels going this way. Then under that panel is the horizontal rays of pixels controlled by these connectors. So both of those work together and makes a picture. Now, I keep talking about these pixels. Let me see if I can get some zoom. So you can see the little tiny wires going to the ends of pixels. These are the horizontal pixels going this way. So each one of those little bars is an individual little light. Every three of those is the three primary colors, red, green, and blue. And with the combination of those red, green, and blue lights, the TV can reproduce any color. Now, each one of these pixels is like a little tiny LED bar almost. So it's like a little bar, and there's groups of three in them. So every three of them is one of the three primary colors, which is red, green, and blue. Depending on what color the TV is trying to reproduce, they put slightly different varying voltages into the different pixels. So with like one of the primary colors being brighter than the other, it'll create one color, because all the primary colors, if you mix them together in the perfect amount, they create any colors possible. So that's how this works. Okay, so I'm not gonna mess with this anymore. I'm kind of afraid to, because it's all sealed up in a vacuum. There might be some kind of gas in it or something. And so I have a big mess to clean up and some huge pieces of glass that I need to figure out how to get rid of, because the garbage will not take these at all. You can see there's parts everywhere. Big metal piece, all kinds of stuff. So this just about wraps up the teardown. Okay, so this here is a RGB light that I made just out of some parts that I had. Now you can see these are RGB LEDs. Now these work on the same principle. They work off of red, green, and blue, and with a combination of any of those colors, it can make any color. So I'm gonna turn it on. It's kind of bright. Here's the three colors: red, green, and blue. I don't think the camera can show, but there's actually individual red, green, and blue LEDs in there. You see the contacts, and then where that little gap is, that's where the red, green, and blue LEDs are. Then with a combination of those colors, it can make any color. Just like this. Now, the same concept for creating color in TVs, it's the same concept. So I'm going to show a microscope view of a close-up on a LCD TV so you can see the individual little pixel bars that create the different colors based off the primary colors. Okay, so I have my microscope here. You can see I have it connected up to the computer. So I have my phone here. Now if I put this on here, you can see the little pixels. You see each one of those little dots is a pixel. Now, for different colors, It uses the same combination of the red, green, and blue, just like I demonstrated on the RGB light that I built. Okay, so I've zoomed in even further, and here is the pixels under extreme magnification. I don't know what color this is, but you can see the red, green, and blue pixels. Now here's just green and red, so that would make a color. See, there's two different colors. You can see the background ones are off. You can see here that's just red. There's blue and green. So all these color combinations of the three primary colors would all create any color, just like the red, green, and blue and the LED light that I had. So that's how LCD technology works. Okay, so I really couldn't find a data sheet for the CPU or the two graphics processors or any of the other chips I was looking at, probably because they're custom chips, and custom chips usually don't have data sheets that you can access. So I did find the service manual, which has some really cool information in it. It has all the components, all the schematics, and everything. Every little component you can find on here. It's really cool. This isn't the exact model, but it's one that's very similar. So I read through this, and there's really some cool information. Not really much information on the chips itself. In the back with the component identification, it doesn't really give much information. It's just labeled IC. Not really much to be seen on those chips, unfortunately. But just finding this here was really neat. Well, this just about wraps up my video. Thanks for watching, guys.